Welcome back to Plastic Ingenuity's Thermoform Circularity Course. My name is Sarah Weber, and I'm a Sustainable Packaging Engineer at Plastic Ingenuity. As a refresher, in Lesson 1, we discussed the basics of thermoforming. In Lesson 2, we learned about the different types of packaging polymers. In this third lesson, we are focusing on recycling. As we learned in previous lessons, plastic thermoforms are incredibly versatile and are used in a variety of food, retail, and healthcare settings. To continue the circular pathway for thermoforms, we must include recycling into the conversation. Before we dive right into recycling specifically, I'd like to discuss something known as the 3 R's. These are reduce, reuse, and recycle. We call this the waste hierarchy. Reduce, reuse, and recycle are more than just buzzwords, but they are principles that guide us to be more sustainable and responsible in our work and our everyday lives. So let's discuss what reduce, reuse, and recycle mean for thermoform circularity. Reduce is the first step in this triad. It emphasizes the importance of consuming fewer resources and generating less waste. For example, the reduce principle could be utilized in thermoform design by down-gauging or lightweighting your material. Reuse encourages us to extend the lifespan of products and materials. This is all about finding value in items that might otherwise be discarded. Lastly, recycling, which is the main theme of this lesson, is the process of collecting and processing materials that would otherwise be thrown away as waste and remanufacturing them into new products. Now, let's discuss a few statistics about recycling. First, the total recycling rate for plastic containers and packaging in the United States is 16%. As shown in this graph, recycling rates vary drastically depending on the packaging material and format. In 2020, about 4.5 billion pounds of plastic packaging was recovered for recycling. However, this still left for 28 billion pounds of plastic packaging available for recovery. Throughout this lesson, we aim to educate you on the recycling process so we can get more plastic circulating through our economy. Just a quick disclaimer, there are a few common terms that are worth knowing when it comes to recycling. These terms are PCR and PIR. What exactly are these terms and what do they stand for? Well, PCR stands for post-consumer recycled. PCR refers to plastics that have been used by consumers. Once their primary use is complete, these plastics are recycled through your traditional curbside or collection recycling programs. PIR stands for post-industrial recycled. PIR encompasses plastics that never reach an end consumer. PIR is created during the manufacturing process and often arises from scrap originating from shaping of products, trimming, modifying production lines, or performing quality checks. For the purposes of this lesson, we will be focusing mainly on PCR, or post-consumer recycled content. At this point, you may be wondering, why is using PCR in packaging so important? Well, introducing PCR into packaging keeps valuable material out of our landfills so it can recirculate in our economy. The demand for PCR also fuels the economic incentives for our recycling industry. Outside of economic benefits, using PCR significantly lowers the carbon footprint of a package and reduces the virgin materials that are used. Lastly, brands are also discovering that using PCR can enhance brand equity among sustainably minded consumers. Now, when we are preparing and designing our packaging to be recycled, we must understand what the term recyclable really means. So let's define it here. What does it mean for packaging to be recyclable? Well, we must consider all 4 pillars of the practice of recycling: collection, sortation, reprocessing, and end markets. As best practice, the Association of Plastic Recyclers defines recyclable as, number 1, 60% of consumers must have access to collection. Number 2, the item must be sortable into material bales. Number 3, it can be processed in a cost-effective manner. And number 4, it must have an end market value. A great resource to ensure your package design meets recycling guidance is by using the Association of Plastic Recyclers Design Guide. The recycling process begins with the collection of materials. This can happen through a variety of methods. The most common method is through curbside pickup, where households will place their recyclables in a designated bin or container, which are collected by municipal or private waste management services. Another method is through drop-off centers, where individuals can take their recyclables to a centralized recycling location. A common example of this would be a store drop-off for a recycling program of plastic bags. Lastly, commercial collection is used for businesses and institutions who have separate recycling for their waste materials. Once the materials are collected, they are transported to a material recovery facility, also known as a MRF. This is for a process called mechanical recycling. Mechanical recycling is the most well-known form of recycling, and it refers to the operations used to recover materials through mechanical processes such as sorting, grinding, and washing. The sorting process at a MRF involves a series of events to separate and categorize recyclable materials from mixed waste. Materials that are typically sorted for recycling at a MRF are paper, including newspapers, magazines, office paper, and mixed paper, OCC, which stands for Old Corrugated Cardboard, glass bottles and jars, metals such as aluminum and steel, and plastics, typically number 1, PET, number 2, HDPE, and number 5, polypropylene. The exact sequence of events can vary depending on a MRF's design and technology, but let's go over a few key steps that can happen in the MRF process. The material is dumped onto a tipping floor where it is loaded into a sorting system. This starts with a conveyor belt feeding the system where it enters a primary mechanical sorting process. Materials pass through a trommel screen to separate items based on size. Smaller pieces like broken glass will fall through, while larger items will continue on the conveyor belt. Disc screens are used to separate flat items like paper and OCC from other materials. And magnets are used throughout the conveyor belt to attract and sort out metals. Throughout the MRF, there are manual sorting stations where workers are positioned across the conveyor belts to manually pick out recyclable materials or remove contaminants. A secondary mechanical sorting process typically includes optical sorters, such as near-infrared or NIR sorting machines. This is a technology that is used to identify and separate materials based on their chemical composition. Since materials have a unique spectral signature, this process uses sensors to analyze the amount of light absorbed by the material. For example, NIR sorting can sort out PET, HDPE, and polypropylene into separate pathways. So, once a material is identified, the sorting system will trigger air jets or a robotic arm to divert the material to the appropriate conveyor belt or chute. Once all the materials are sorted, they are compacted into bales to be sold and transported. For plastics, further reprocessing will occur at what we call a reclaimer. A reclaimer is a specialized facility where sorted recycled plastic is processed and prepared for reuse. The primary goal of a reclaimer is to transform recycled plastic into high-quality flake or pellets that can be used as raw materials by a manufacturer like Plastic Ingenuity. Now let's go over what a typical process at a reclaimer looks like. First, plastic recyclables are delivered to the reclaimer from a MRF or industrial site. Just when we thought all the sorting was over, there's actually an extensive amount of sorting that occurs at the reclaimer level as well. For the sake of this lesson, we are going to focus on a PET reclaimer. At the start of the reclaimer process, more sorting occurs to separate clear PET from colored PET. Mechanical grinders and cold wash stations will work to remove contaminants such as non-PET labels, adhesives, or food residue. Once the primary mechanical sort is completed, the material is shredded into small pieces. We call these small pieces flake. The next step in the process is the float sink tank. This is also known as a separation tank. The float sink tank is a crucial component to the process of reclaiming. It is used to separate different types of plastic that may remain on the flake based on the density of the material. Specifically, this process aims to gather PET away from other plastics such as polyolefins from labels and other contaminants. The flake will enter the float sink tank, which is usually filled with water. Since PET has a higher density than many other plastics, we will see the PET sink to the bottom of the tank, while other lighter plastics will float to the surface. The floating material is then skimmed from the surface while the PET is collected from the bottom of the tank for further processing. Now, the use of post-consumer recycled PET in FDA-approved food-grade plastic packaging requires careful consideration. This includes the removal of volatile organic compounds, known as VOCs, and the use of a hot caustic wash. Ensuring the safety and compliance of recycled PET for food contact applications is incredibly important. VOCs are organic chemicals that can potentially migrate from the recycled PET into food packaging products. VOC removal typically involves the use of a specialized equipment and process, such as a vacuum, to remove the volatile compounds from the recycled PET. Next, a hot caustic wash is a chemical cleaning process used to remove contaminants and impurities from PET material. During the hot caustic wash, PET flakes are typically immersed in a hot alkaline solution containing sodium hydroxide. The combination of heat and alkalinity helps break down and remove contaminants, including adhesives, labels, and some types of inks. The hot caustic is important to remove any last surface contaminants and boost the overall cleanliness and quality of the recycled PET so it meets FDA food safety standards. After these steps, the flake is dried to remove excess moisture. Sometimes the flake is pelletized before it is sold. However, both flake and pellet form of PCR is acceptable. As we mentioned earlier in this lesson, end market values and recycling rates will differ between plastic types. So what happens to plastics that are not typically collected during a mechanical recycling process? This is where advanced recycling comes into play. Stay tuned for our next lesson to learn more about how advanced recycling benefits thermoform circularity.